I'm P.K. Mohanta, Professor IARE, Hyderabad. We are continuing aerodynamics classes on potential flow, and the same potential flow there are different topics. So all are welcome to the class. Like we are having a series of class and we are doing for the like today's is my fourth video recording for this potential flow. So let us look about that. Today we are going to talk about the Laplace equation. The Laplace equations, it is how it is derived. Okay, so we will talk about the Laplace equation, and this is the we have to make the basic fundamental incompressible flow continuity equations we have to consider as a dou u by dou x plus dou v by dou y is equal to 0 that is my equation 1. The equation of vorticity, that is dou v by dou x minus dou u by dou y is equal to j, will be my equation number 2. You assume the stream function, that for the incompressible flow psi, it will describe the continuity flow in 2 dimensions where the velocity at any point will be given by, you assume that one u is equal to, we know it, dou psi by dou y is equal to 0, and v direction, that is the y direction, velocity will be minus dou psi by dou x, and let it be my equation number 3. These are the 4th equation we are going to consider. The third, all 3 we have done it. Equation 1, continuity equation, vorticity equation, and that is our the velocity u and v 2 components in terms of psi. We have taken it. The stream function, again for the incompressible flow only, phi, which is the continuous in 2 dimensions where the velocity at any given point will be u is equal to dou phi by dou x equal to 0 and v equal to dou phi by dou y. Let it be my equation number 4. These two, that equation number 3 and 4 in terms of the psi and phi, that is our velocity potential and stream function. So with this fourth one we should remember, and we should utilize this to derive the Laplace equation. So if we look the Laplace equation, substitute now 3 in 1. That means which one? The third one, that is the u and v value in the 1 in continuity equations. If we will do it, what we will get? Dou square phi by dou x dou y minus dou square psi by dou x dou y equal to 0. With demonstrates the validity of equation 3. That is that equation 3. That is the same way we have seen that equation 3 is our. With this we are able to do it. With this now, which demonstrates the validity of 3, while now we will substitute equation 4, that is the the velocity potential, and that is our fourth one is our stream function. The stream, no, it is a velocity potential. It is somewhat wrong. It is a velocity potential. With this, if we will look it, what we will get? Dou square phi by dou x dou y minus dou square phi by dou x dou y equal to 0. Now, demonstrating the validity of 4, that is the flow describes by the unique velocity potential must be irrotational. So then in case that is the validity we look for, then what we will get? We will get the alternatively substituting equation 3 in 2 and 4 in 1. Then what we will get it? That we will get the criteria of irrotational and continuous flow. And if we will do it, what we will get? Dou square phi by dou x square plus dou square phi by dou y square equal to 0. Dou square phi by dou x square plus dou square psi by dou y square equal to 0. So this one we call it is our Laplace equation. Also, in some books, they write a del symbol, they write, right, like this. So what they can write? So that means both are 0, right? Del that is a del square phi by del square psi, both are equal to 0. So this way some books they write like that, and for some students or maybe some readers it is difficult. So in that way I have written in the form like this. But where in this way, that means when the meaning of del means it is equal to, or del square means it is equal to dou square by dou x square plus del square by, or dou square by dou y square. So in some books they write the Laplace equation in this form, some books they write like this. So don't get confused, both are having the same meaning, only the our del how they write it. Okay, so Laplace equation is derived like that, and it is I believe that is simple. Only thing we have to remember, continuity equation and our other rotational flow equation, if you will write it, rotational flow equation, then what will happen, and substitute the psi and phi value, and then you equate it, you will get a Laplace equation. Now we will see what is the relation between psi a value and phi value, that is the u and v for psi and u and v of phi. This relation we will look into. Okay. So this is pretty interesting because we have seen it. How we have seen? Let us see. We know that is the velocity direction in x is equal to minus dou psi by dou y, and that is nothing but equal to u and v. In the x direction, this is my x direction, this is in the y direction. In terms of psi, in terms of stream function, right? In terms of stream function, if the value comes like that. Same way, if we look it in terms of the phi value, how the u and v value comes? U and v value, it comes like in the x direction and y direction. If we look it, that is minus of dou phi by dou x and v value, that is the y direction, is the dou phi by dou y. So that one, let me little bit elaborate it here. Here, in case this is the x direction and y direction, that means when there is a flow is like that, and this one, it will have the my two component. One will be the horizontal, one will be the vertical. Horizontal component is u and vertical component is v. Right? So with this, these are the components we get. But what is the relation and how they behave? This should be the universal truth. So let us look about that. And for that, if we will look it into more details, we will get that dou phi by dou x, dou phi by dou x is equal to dou. That means this u value and this u and this one should be the same, right? This u value, whether in terms of a psi u stop or in terms of phi u speed, both are having the value is same. The direction in the x direction, velocity component is constant. So in that case, what will happen? Dou phi by dou x is equal to, okay, or minus dou phi by dou x is equal to dou psi by dou y. So in that case, both minus and minus will get cancelled, and lastly we will get dou phi by dou y. Correct. Similarly, if we will component the vertical components, vertical velocity components, what we will get it? This v equal to the, in terms of the, that means velocity, the vertical components, whether you do psi or phi, both are same. So in that case, what we will get it? We will get it, the if we will equate it, dou psi by dou x is equal to minus of dou phi by dou y. So we got the two things. But if we take the slope, if you will take a slope of it, anywhere if you will take the slope dou y by dou x, you will get, if you take the velocity component and then that is the velocity potential, then we will get u by v. And in case we will consider the slope of the velocity of stream function, and dy dx will give the slope, and this will give us the minus of dou v by dou y. So we'll get in this two way. So what is the relation? But I believe during our uh, coordinate geometry we have studied, if we multiply both the slopes and we observe there or we notice their results. In case the result is coming as minus 1 means they are orthogonal to each other, right? That means if we will say the two lines with slope that are negative reciprocal of each other, are perpendicular to each other. If that is negative reciprocal of each other, that means they are perpendicular to each other. That is the relation between them. So in case, that means how it looks like, let us have a look. If you look, suppose one component is going like this, in this direction, obviously another component will come like this, the gradient, and they will be intersect psi and phi at any given point, at orthogonally they will intersect. That is the slope m1 dot m2 is equal to minus 1. I believe this one is, everybody knows it. So right, this is the relation between psi and phi. So thank you very much for this one, Laplace equations and the relations between the psi and phi. The most of the things will be simple hereafter.
Like, share and subscribe. Hit the bell icon for more updates.